Welcome back mga kabulero at ito ang continuation ng ating discussion sa pagsusolve ng mga kinetic problems. This is problem number 2 and the problem says a woman on an elevator weighs 110 newtons. So compute for the force exerted by the woman on the floor of the elevator if it's accelerating upward at 3 meters per second squared. So the other problem is just the reverse. Compute for the force exerted by the woman on the floor if the elevator is accelerating downward with the same acceleration at 3 meters per second squared. So parehas ng pagsosolve natin from problem number 1, gagamitin din natin dito yung Newton's second law of motion computation and also yung D'Alembert's principle computation. So let's begin by drawing the system's free body diagram. So, ganito yan. Ito yung elevator. Siyempre, merong babae na nakatayo. And then, meron siyang tali, siyempre. And we have the downward force, which is the weight, 110 newtons. And yung acceleration is, for letter A, it's going up. Therefore, kapag kapataas yung elevator, iset lang natin yung expectation na yung force exerted by the woman on the floor of the elevator is bigger versus kung yung elevator is going downwards. So, malalaman natin yan mamaya or marirealize natin yung sinabi kong principle na yung force exerted by the woman pagpapataas is mas malaki kapag pababa ito. So, ano ba yung magiging force na magre-represent nung force exerted by the woman? So, that would be force of the woman exerted. Since ang magiging direction nung force exerted by the woman ay pasalungat doon sa weight, 'di ba? Doon sa movement ng elevator at this point. So, ano nga ba yung magiging formula natin? Summation of forces along y-axis going up is positive. Sulat natin as Fw, okay? Minus the weight. So, meron tayong mass times the acceleration due to or in the y direction, okay? But we don't need the acceleration in the y direction right now. Gamitin na lang natin muna is ma. So, ano nga ba yung force along y-axis? That would be, we can represent it as MA, okay? MA, pwede sabihin natin MAY, is equal to, ito yung hinahanap, the force exerted by the woman, minus the weight. So, to solve for the force exerted by the woman, edi, gagawin lang natin, itatranspose natin yung weight sa kabila, at magiging siyang positive. Magiging plus MAY, and we know the acceleration going up is 3 meters per second. And the weight is 110 newtons, plus, yung mass, we can definitely compute for the mass as we have the weight, di ba? So, i-divide lang natin yung weight sa gravity. That's 110 newtons divided by the gravity, which is 9.8 meters per second squared, di ba? Multiplied by 3 meters per second squared. Okay? So, cancel out na to. At ang force exerted by the woman if the elevator is going up, again, walang consideration dito ng bigat ng elevator. Pinag-uusapan lang natin dito is yung force exerted by the woman. So, that's 110 plus, we have 110 divided by 9.8 multiplied by 3. Okay? Sana nakasunod. And the answer here is 143.67 newtons. Napakadali lang. Basta't alam natin kung ano nga ba yung force at yung mga magiging direction ng forces sa ating free body diagram. So let's move on using the D'Alembert's principle. At ano nga ba yung magiging formula nito? So ang formula nito is, syempre meron na tayong free body diagram. We have the force exerted by the woman minus yung weight, kasi salungat yung weight, and then minus REF, or the reverse effective force, which is equal to 0. Okay? So, yan lang magiging kaibahan. Pero kapag kinuha na natin as REF as MA, so F, force exerted by the woman, ilipat na lang natin yung weight, magiging siyang positive. Tapos, ilipat natin yung ref, tapos i-convert natin siya into MA notation. So, kung titingnan natin, weight, tapos mass times acceleration, parehas na parehas lang yung format. That's 110 newtons plus mass computation, that's still the same, 110 newtons divided by 9.8 meters per second squared multiplied by the acceleration, which is 3 meters per second squared. Siyempre, hindi na natin i-compute using our calculator. It should be the same, 143.67 newtons. So, pinakita ko lang sa inyo na kahit na magkaibang approach, basta alam natin yung notation ni Newton's second law and then D'Alembert's, kahit alin yung gamitin natin, parehas yung magiging solution. Alright, so this were our computation for letter A scenario. Alright, for letter B, the scenario is just the reverse. Compute for the force exerted by the woman on the floor if the elevator is accelerating downward at the same acceleration of or at 3 meters per second. So, magiging baliktad lang yung consideration natin, pero this time, gagawin ko is yung summation of forces along y-axis. Going down would be positive. Kasi nga, going down yung direction natin para maging positive yung mga forces going downwards. So that will be, my weight would be positive and my force, or the force exerted by the woman in the elevator, will be negative. So Fy will be MAY is equal to weight minus the force exerted by the woman. So gagawin ko lang dito is ilipat ko ngayon yung force exerted by the woman sa kabila, magiging positive, and then weight stays the same, pero yung MA ko magiging negative. Okay? MAY. So weight is 110 newtons minus mass, kung isosolve natin yung mass, that's 110 newtons divided by 9.8 meters per second, that's my gravity squared, multiplied by 3 meters per second squared, which is my downward acceleration. So the exerted force of the woman to the elevator going downwards, okay, is 110, this time minus, kanina it's plus. So that's 110, 9.8 multiplied by 3. So the answer is 76.32 newtons. And as expected, or 76.33. So as expected, mas mababa kasi paayon yung weight nung babae doon sa direction ng elevator. That is why yung force exerted by the woman to the elevator is much more less compared to what we have computed pag papataas yung elevator. Kasi pasalungat yung bigat ng babae. Now, using D'Alembert's principle, mababago lang naman yung treatment natin dito. Kung kanina yung force of the woman yung nasa umpisa, gawin na lang natin weight minus, diba? Kasi pasalungat, ang consideration natin is everything that goes downward will be positive. That's why we have weight minus yung force exerted by the woman, okay, minus REF is equal to 0. Okay? So magdedepende yung formula natin sa direction ng force. Okay? So, we have, ilipat natin yung force exerted by the woman. We have weight minus REF. Diba? Kasi si REF, reverse effective force, lagi siyang pasalungat. So, salungat siya sa downward na movement. So, we have 110 newtons. And REF, let's just convert this to MA. Okay? And MA is mass 110 newtons divided by 9.8 meters per second squared. At same lang, 3 meters per second squared. And we have force exerted by the woman is 76.33 newtons. And that's pretty it for problem number 2. Napakadali lang versus yung number 1. Madami tayong sinolve sa number 1. Alright, so hopefully natuto kayo in computing kinetics using Newton's second law of motion and D'Alembert's principle. Ito naman, this is about vertical motion. Kung sa previous problem, we computed horizontal motion. This time, it's vertical motion. And wala tayong friction dito kasi hindi natin tinake into consideration yung friction doon sa kable ng elevator. Ang diniscuss lang natin dito or ang kinompute natin dito is the force exerted of the woman by the woman in the elevator. Alright, so one last problem at abangan natin sa susunod na video. Thank you!